Okay, we're going to talk a bit about the t-test. And what I did is I pulled out this picture out of the PowerPoint. And let's talk about this first one, this t-test. Excel doesn't do a good job on this. And I'm just going to punt. I'm going to go back to the z-test and just use it like the previous film. If you got a sample, you know the population average, population standard deviation, then just use that. This one you got to do a lot of calculating just to use Excel. So if you want to, I'll get into it, but I'm not going to do it for everybody else. So what I want to start off with is two mean equal variance test. So I got two samples here. Let's say we're talking about fruit off a tree. So I got sample 1 and sample 2, just two samples. So the way I would use this is I'd come in, equal to t-test. It comes up array 1, comma, array 2. And I want two tails. That means it can either be bigger or less. I don't know what it is. But a big assumption here is that the variance, the standard deviation and variance, are kind of equal. We don't know that for sure, but we're going to take that. So a two-tailed test. And I want equal variance. Okay. Close this thing off. So what I'm saying is 95% chance, 95.85% chance that the difference I'm seeing is just random variation. Now the reason we consider the variance on this is because this is a test of the means. We're comparing the two means, right? So, well, let's say I did a one-tailed test. What if I thought it was, well, I'll just type it in. Let's see what happens here. So again, my X in this, well, I said I wasn't going to do that. T-test, it's array 1, array 2, one-tail test, and again I'm going to consider equal variance. So that's telling me that there's a 47%. So what I'm basically looking at here is the average here is pretty much spot on between the two. Okay, let's do this other case. Considered unequal, and don't worry about this Welsh Satterthwaite. What they're doing is they're just taking our array sizes and they'll calculate the degrees of freedom for us. So I'm going to come in again as t-test, array 1, comma, array 2, comma, I'm just going to go with two-tail, and type, I want, oops, comma, variance are unequal. This is heteroscedastic. That's a tough one to say. And again, it's 95.86. Not much difference, right? And what happens then is because, well, I won't get into it, but if the variances are different, this number will be significantly different from the other one. The last one I wanted to do is a paired t-test. So let's say, let me insert some columns here. I look at the trees, and this is year 1 and year 2. Oops, let me do this better. Year 1 and year 2. So each tree, this is what I got off last year, this is what I got off this year. And I say, man, it's not doing as well this year or whatever. I want to compare that. So I number the trees 1 through 20. Well, 1 through 20. Don't make me do this, Excel. There we go. So then I can say, okay, this is paired, right? And it pivots off the tree. So then I can come in and do a t-test. Array 1, that's last year's data. Array 2, this year's data. I'm just going to do a two-tail. I'm just going to call paired. And again, you can see the odds got a little bit less. This is the t-test, the 3 cases we have. If you're going to do the sample compared to population, I recommend you use the z-test.